Hello students, in today's lecture I will discuss about visible surface detection methods. So in visible surface detection methods, these are also called as hidden surface elimination methods. We have to identify the faces of any three-dimensional object, whether which faces are visible from certain viewing position. So here in the figure you can see that this is a cube, and you can see that this face of the cube is visible if I am viewing from this position. This face that is at the top is also visible, and this face which is at the right side is also visible, but the face which is at the bottom and the face which is at the back and the face which is at the left side of the cube, these faces are not visible. So we have to display all those faces which are visible from certain viewing position, and we have to eliminate all those faces which are not visible at certain view position. So for this we are having so many algorithms, and this algorithm requires more memory because uh, it is dealing directly with the object definitions and the projected images, so it requires more memory. These algorithms require more processing time, that is the execution time, and there are some constraints of this algorithm because this algorithm depends on the shape of the object. So deciding a method for a particular application, so which method will be good for a particular application, it depends on the complexity of the scene and the type of the objects, and whether we want to display a static or animated image of an object. So the algorithms can be categorized into two ways. First is object space method and second is image space method. Object space method deals directly with the object definitions, while the image space method deals with the projected image of an object. That means first we do the projection, then we will decide which faces are visible. So object definition directly versus their projected images. Most visible surface algorithm uses image space methods. So there are so many algorithms which are using image space method, but there are only few algorithms which are using object space methods. And especially the line drawing applications uses object space method. In object space method, it compares objects and parts of the object to each other, while in case of image space method, it do point by point comparison of the pixels on the projection plane. That means here we are dealing with the pixel by pixel locations. So the first algorithm is backface detection, and this is an object space method. It identifies back faces of a polyhedron. So here in the figure you can see that this is the polyhedron, and it is having various faces, and this is my viewing position, or from this position I am viewing the object, or this is the position of my eye. So here you can see that this is the front face, so I have to keep this face as visible, while this face is basically it is a back face. So what I have to do, I have to hide this back face. A point x comma y comma z is inside a polygon surface with the plane parameter a, b, c and d if a plus by plus cz plus d is equals to 0. So this is the plane equation, and if we are saying that any object is lying inside the this polyhedron, so certainly it will satisfy the equation, and the equation is ax plus by plus cz plus d is equals to 0. When an inside point is along the line of side to the surface, the polygon must be back facing. So here you can see that whenever we are saying that any point is lying along the line of sight, correction आ गया इसमें. So the first algorithm is backface detection, and this algorithm is based on object space method for identifying backfaces of a polyhedron. A point x, y, z is inside a polygon surface with plane parameters a, b, c, d if ax plus by plus cz plus d is less than 0. So here in the figure you can see that this is the polyhedron and it has various faces. This is my viewing position, or this is the position of the eye. So here you can see that this face is visible while the face which is at the back is not visible. So if I am saying that any point is lying inside this polyhedron, so certainly it will satisfy the plane equation and its value would be less than 0. When an inside point is along the line of sight to the surface, the polygon must be back facing. So here we are taking a normal vector, capital N. Capital N is the normal vector to the polygon surface, and A, B, C are the Cartesian components of that vector. Vector V is the vector which is along the viewing direction, that is along the direction of the camera or eye. So we can say that any face of a polygon is backfacing if the dot product of V dot n is more than 0. Because we can see that V dot n is equals to modulus V modulus n into cos theta. Here the angle is 0, so cos 0 is 1. So we can say that the value of V dot n is more than 0. So the vector V could be defined as 0, 0, Vz. Vz is the viewing direction. So we can write V dot n as Vz dot n, where n is the coefficient along the z-axis. Now we can say that the viewing direction is along the negative zv axis. So the position where we are viewing the object, it is along the negative z-axis. So we can say that the value of the coefficient c is less than 0. Okay. Also we cannot see any face whose normal has z component c is equals to 0. So from these two terms we can say that the value of c is less than equals to 0. That means any polygon is backface if its normal has z component value less than or equal to 0. So we are comparing the different faces of the polyhedron, and if for any face if the value of c component is less than equals to 0, then we can say that the face of the polyhedron is not visible, and we will hide that face and the other faces would be visible. So this is all about this algorithm, that is backface detection. Thank you.
ये अटैक ऑन इंटेग्रिटी जो होता है सर,